Welcome to the why and how of TypeScript. It's so nice to see so many people here eager to learn about TypeScript. First, a small disclaimer. I have a cold, as I usually do when I'm presenting stuff. So if my voice disappears, we will have to quickly learn sign language, everyone. But I have a big cup of tea with lots of honey, so I think I will be all right. Feel free to ask questions anytime. Use the hand thingy in Zoom, or just write in the chat, and I might answer it immediately. But there will be space for questions at the end. This will also be talk 1 of 2, because I apparently have quite a lot to say about TypeScript. So in 2 weeks, I will do a follow-up with some more advanced topics, perhaps. We'll see. And you are all, of course, welcome to that as well. But I will post about that. Right, let's get started. There we go. What is TypeScript? So from typescriptlang.org, which is TypeScript's homepage, it's a strongly typed programming language that builds on JavaScript, giving you better tooling at any scale. But what does that mean then? So it's a separate language from JavaScript, but when building, it gets compiled down to plain old JavaScript, and that's what's being shipped to your client's browsers. And strongly typed in this context means that you specify what type everything is. It can be strings, numbers, booleans, custom types. You people coming from app development are at home with typed languages, I presume. But this is not the norm for web development. It's starting to get there, but yeah. So why should I use TypeScript then? Well, this presenter thingy does not work reliably. Let's try again. Yes. Well, what if I told you that you already are? Probably. Not all of you app developers, but everyone that uses VS Code, for example, as an IDE for development, uses TypeScript. You just don't do it manually. So VS Code is built on TypeScript, and that's what's powering the whole IntelliSense functionality in VS Code. So in this example here, if I make an array with a couple of numbers and then map over them, TypeScript, if I hover on the my array, it will say, oh yeah, that's an array of numbers, and I will get auto-completion for .map, because TypeScript knows that, oh yeah, arrays have a map function. So a lot of the auto-completion stuff you already are using comes from TypeScript. And a small aside here, let's might have to skip this one. The syntax down there at the bottom, the comment with a caret and a question mark, it's something called 2/ queries. I don't know if that's applicable in other languages, but in TypeScript, you can use this to get an interactively updating comment about the inferred type. So if I write this in my editor will automatically expand that to say, oh, const my array equals number array. And that you can use for anything in TypeScript if you don't want to hover over stuff, but to actually see what is being inferred. And this works partly on the playground at typescriptlang.org, and it works in VS Code if you use the plugin VS Code 2/ queries, which is really handy when you're doing complex types and trying to figure out what is actually going on. Right, back to the array example. So if we have this, that doesn't work. There we go. Let's say we have an array here. And if I were to write my array dot, I will get all of the functions available for an array. So let's say I want to do map, yes. Map num equals whatever. And here, inside of the map function, I also get autocompletion for the num parameter. Typescript knows that, oh wait, this is probably a number, since you passed in an array of numbers. So you'll get autocompletion for all of the number functions. If you were to write something wrong, like stringify, a method on the JSON class, you will get an error saying property stringify does not exist on type number array. You will also get errors if you try to call something that isn't callable. My array isn't a function, it's an array. So TypeScript will say, oh, this expression is not callable. So it sort of saves you from doing weird errors when building and then trying to figure out in browsers. So if you have TypeScript, you will get this by automatically. Right. And if we want to extend this autocompletion and error handling, we can define our own types. Let's say we have an interface. I will go through the syntax later on, but let's say we have a type that describes how a user look, which is a normal JavaScript object with an ID, a name, and a number of posts, and they are strings and numbers. And then I create a function that takes an input, which is a user, and then we'll log input.number of posts. If we then call this function with an object that doesn't meet our requirements of it being a user, we will get an error in TypeScript, and the error will say property number of posts is missing in type. So here TypeScript says that, oh, you can't call my function with this object because we require number of posts property to be there. So a short recap on why, and you will get more whys later on. You get autocomplete in your editor, and you get that for free, even if you're not using TypeScript in your project. You get documentation for standard methods. If you hover over the map function, you will get a description of how it works. And if you start implementing TypeScript in your own project, you will also you'll catch errors when developing instead of shipping them to users and getting errors in the browser. And it covers edge cases automatically. Say you have a function that in some cases returns undefined. Say you have a switch statement with no default, then that function will return undefined in some cases. And TypeScript lets you know that, because if you try to use that return value somewhere and don't check if it exists, it will throw an error saying, oh, this might be undefined, which solves that pesky cannot read property null of undefined error we've seen in the browser so many times. And in my experience, TypeScript also reduces the amount of hopping between files. Because if I write a function that returns something and then go to use that function, I immediately forget what I wrote as a return type. And with TypeScript, I can just hover over the function and see what I wrote. So it makes me a much more efficient programmer, because TypeScript can remember stuff that I apparently can't. Let's do some hows then. So TypeScript is what's called a duck-typed language. It's also called structural typing. And that comes from the old saying that if it looks like a duck, and it swims like a duck and quacks like a duck, then, well, it's probably a duck. So TypeScript is partly meant to prevent runtime errors. If you pass extra properties in an object to a function, JavaScript doesn't care, and neither does TypeScript. What do I mean? Let's see this code example where we have an interface which is a user and it has a name. And then I create a function that takes in the user and I do something with user.name. If I call this function with an object that also has an address, when this gets compiled to JavaScript, it just, yeah, that doesn't matter. An extra property doesn't matter. And this is different from the previous example where we didn't pass enough. We didn't pass all of the variables. Here we pass all the variables we require. Name is in the object, but we also pass something else, which is perfectly fine. And this means that sometimes you have to rethink how your code works. An example we had in the Swish project recently was that if we just pass along the input parameters, in this case, let's say we pass it along to an external API, then we might get weird errors since we are not controlling the external API. TypeScript's type safety ends at the edge of the browser when it's calling to API. So then we don't know what happens in there. So if you call this my function with the same object with name and address, that API might do something with the address property. We don't know. So in this case, where you're calling external API, when you're leaving TypeScript land, my proposal is to be specific. Create a new object inside my function that is on the format that the API is expecting. Don't just pass along variables. And you don't need to, and you really shouldn't type everything in your code base. TypeScript is a really strong inferred language, so it can figure out what types are what really easily. And in this example here, you can see that my array, it's an array of numbers. I don't have to specify that. Just by passing an array of numbers, it gets that type. If I then do a concatenate function, where I take in an array of numbers and return that array joined by a dash, I can see that the result of that function call will be a string, because numbers.join will return a string. I don't have to be explicit in saying that this function will return a string. You get that for free. Note here, however, that we do need to type the input to the function. Otherwise, we don't get any type safety that way. We can't infer after the fact or before the fact. You can't look in TypeScript can't yet look into the future. Who knows what ChatGPT will bring. But let's get to some syntax then. Specifying types, as you've seen in numbers of I'll get to your question shortly, Emilio. You've seen that we can declare types by putting a colon at the end of the variable name. In this case, we don't need to, since TypeScript knows that 6 is a number, but this is how you type stuff. If you type objects, that's the same thing. You write the colon after the variable name and then your type. And typing functions, you've seen that we type input parameters by putting a colon and the type in the input list. And then we have a colon after the parentheses and then your return type if you want to specify it explicitly, which you do from time to time. And specifying a return type makes you catch errors when you're not returning the correct stuff later on as well. Emilio is asking what happens if you have two interfaces that are identical. What does an argument type resolve to? I'm not really sure what you mean. If you have two interfaces that are identical, do you want to elaborate, Emilio?
Yeah, so if you have two, I don't know, two things that have like a name and an email, say a seller and a buyer, do they get inferred to be either a seller, or does an object get to be inferred into one of these?
No.
Um,
You will never infer into your own interfaces.
okay. So it will be from context that it's decided what it is rather than figured out. Like,
Yeah. So if you would have an object, an interface, or let's say you have an object with a certain properties, the inferred type of that will be the structure of that object. So it will have the keys you specified, and then the types inferred from those. So it will be name, string, and ID number. But if that matches your interfaces, it's perfectly fine to put that object typed as that specific object into a function that expects buyer or seller, since it matches the structure.
okay, so it doesn't get assigned a type. It's just like, oh, it's an object with these fields.
Yeah,
So it will be compatible with
yeah,
either of those interfaces.
yeah.
Okay, cool.
Uh, a bit more on typing functions. So this is the example from last slide where we type input parameters and return type. We can also write our function type separately, like this. So instead of a const, we write type to specify that this is a type alias. My function type equals our list of parameters and their types, and then an arrow and then return type. This is basically the only place in TypeScript where an arrow is denoting the type instead of a colon. Why they've done this, I don't know. It seems weird to me, but probably some parsing stuff. I don't know. But specifying the type like this as a separate type, we can then type our function as the complete function type directly after the function name. So here's a pothole that you can fall down in. So if you have a colon in, let's say we have an arrow function like this. If you have a colon after the function name, the type is for the whole function, including parameters and return parameters. If you have the colon after the parentheses, that's the return type. And it's easy to get those mixed up. Be on your guard. We have some basic types. We have primitives, which are numbers, strings, and booleans. We also have the type undefined and the type null, which you've seen we can, if we get undefined return, the type will be undefined, which is also a primitive. You have arrays, which we've seen, number, you type it like this, number, and then an empty square bracket. You also have tuples, and tuples are basically arrays of a fixed length. So here we say that the tuple, my tuple, is an array of 3 elements where each item is a number. And this can be useful for certain cases. I won't go into them. You will figure those out. Another way of defining a tuple is by using the type assertion as const. And this takes the array we're putting in this case, the array 1, 2, 3. And the type of this will be a read-only array of 3 length with the items exactly 1, 2, and 3. So it's no longer number, 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 it's the actual literal array. This can be useful for when you want stuff that's not mutable and want TypeScript to know about them. We'll get to any, Henrik. We'll get to any. Typing objects, and this is, I think, the most types you will write in a TypeScript code base. The first way we've seen already, you write the keyword interface and then your type name, and then a bracket without the equal sign. Careful to not write the equal sign before the bracket. And then you write properties and their types, and just as if you would do with a normal JavaScript object with keys and values. You separate each line with a semicolon in this case, and not a comma as you would a JavaScript object. And here you also see that I have an optional property which has a little question mark at the end. And that means that you don't have to have that in your object of this type. And what it does is basically say that the type of optional property is number or undefined, since that's the way JavaScript object works. You can also define object types like this using the type alias keyword. Here you do have the equal sign though, otherwise they're identical. And you're using object types by the same way as we've seen before. So now you might ask, why are there two ways of typing objects and what's the difference? And basically it's not really a difference. It comes down to preference. There are edge cases and they are different, but you probably won't get into that quickly. I tend to use interfaces because when I get into the nitty-gritty, that's the difference I want. It's about extending stuff and basing types on other types. Union types is next, and this means that we can specify multiple types in an either-or scenario. So here we have our user interface where the ID is either a string or a number. Say we have some wonky backend that doesn't store IDs in a correct way where we have both of them. Then we can specify that, oh, the ID is either a string or a number. And if we look at this array here, my array equals the elements 4 and hello, that will be typed as an array of string or numbers. And there are these two lines here, lines 1 and 2, my mixed array type 1 and 2, are different, but they are really important. So for the first one here, we say that it's an array of numbers or an array of strings. And we have 3 test cases here. The array 1, 2, 3, and 4 works fine. The array A, B, C, and D works fine. But if we mix them, we will get an error. Because what we're saying is that either the entire array are number or the entire array is based on strings. You can't mix them. In the second case, we say that, oh, this is an array of elements that are either string or numbers. So here all of the 3 examples work fine. Literal type then. It's when you want to constrain stuff. Let's say string isn't strict enough. Let's say we have this this user interface here where the ID is a string or a number, and the name is a string, and the state is the string, the literal. Hey, wait, you're not seeing this. Sorry, let's go again. There we go. We have an interface user with an ID, string or number, a name or string, and the state is either the literal string subscribed or the literal string inactive. So all objects that we type as being a user will have the state property, and that will be either subscribed or inactive. So down here I've created me with an ID, a name, and the state. And if I then, let's say I want to subscribe, or I subscribe, I will want to update the state here. So then I write user pair dot, and as soon as I write dot, I get auto-completion for all of the properties of user, since I know that user pair is a user. Now I want to update state. And for some reason, auto-completion here doesn't work in this playground. It works in VS Code if you click Control Space, I think. So then you would get both subscribed and inactive as options. Here I have to write the letter. No, I were subscribed. And then I will get subscribed, since those are the only valid options. And let's say somewhere else I'm getting inactive again in div. We can see here that, oh, I get an error. Type inactive is not assignable to type subscribed or inactive. Did you mean inactive? In this case, my spelling error was close enough that it actually gave me a suggestion as well, which I think is really neat. Inactive. And now some of you might say, but why are you using strings here? Shouldn't you be using enums? Like my enum. Subscribed, inactive. And the way you're using this is then by typing my enum.inactive. You can, but you really shouldn't. Enums doesn't behave as you think they do, especially given what they are transpiled to. So if I, in this playground, switch over to the compiled JavaScript, my enum is compiled into this weird mess. And I won't go into more details on why they're bad and edge cases and possible solutions. You can have a look at the video called Enums Considered Harmful by Matt Pocock on YouTube that goes through why TypeScript enums are weird. And the creators have also said that, yeah, that wasn't the best thing we did. So use magic numbers or magic strings, which aren't really magic strings in this case, since TypeScript says that, oh, they are these literal strings. Right, let's go on to type narrowing. So type narrowing is when you have a quite general type and want to drill down into what the actual type is. So in this example here, we have an interface user and an interface company. They both have an ID, although the type of ID is different. The user has a name, while the company has a legal name and a public name. And then we have a type property, which is, in the user case, the literal string user. Any object we create of type user, we have to add user as the type. The same with company. And then we can specify that our type member is either a user or a company, because let's say our system supports both. If we then write a function to print the name, let's say we name a function print name, and then we have a member input, which is of type member, which, remember, is a user or a company. Then we log the member name to console. Here we will get an error. It will say property name does not exist on type company. It exists on type user, but the input is either a user or a company, so it could be company, and company doesn't have name. So what we can do then instead is to do this type narrowing here. So we're checking if member.type equals user, log member.name, otherwise log member.public name. And as you can see by this /query, is that member inside of the if is being narrowed to a user. So inside of that if statement, member is a user. And the same way in the else statement, since our member can be either user or a company. Well, we've already checked that if it's a user, do this. The only remaining case is that it's a company. This is a really strong way of narrowing down types. And this isn't strange, right? Because the thing that gets compiled to JavaScript is what you would do in JavaScript. Oh, we need to check if something is something. Well, let's add a type to the object we have, and if we have a type user, we can do this, and so on. So it's just JavaScript. Hannes asks, can you bypass having the type in both interfaces, like in Kotlin X is Y? No, because you need to specify the value of it. So you have to say that type is the literal string user in the user case and the literal type company in company. There is a thing called type predicates, which I won't go through this talk, but will in 2 weeks, where you basically have a function, a plain JavaScript function that somehow differentiates your two objects. And then you can add on a small TypeScript thing that, if A is correct, if this function returns true, the stuff you entered into the function is of type whatever. So then you won't have to have this type. Then you could check for the existence of a name or so on. Can you add a switch on type? Yeah, I mean, depending on what you mean with type. If you by type mean...
Yeah, I can. Sorry, it was hard to write, but can you sort of if you switch on type, will it be able to figure out that you're switching on a user or a company?
If you mean switching on this type, yes.
Yeah.
Switches are basically if statements change, right? So it would be the exact same here. So you could do switch member type and then user company.
Right. But does TypeScript, can it enforce that behavior? Like, for instance, if you would add another interface to the member type in the future, and you have a switch for the type, would it pick that up?
Good question. I don't think it would throw an error, because it's not an error, right? In this case, it would be an error. Let's say we add a member kind that does not have a public name. Then this line will throw a TypeScript error, since in this else statement, it can either be company or whatever new type you have.
Right.
So I guess you could write something in the default statement to catch those cases somehow. I'm not sure how you would do that. Right, Henrik, here's any. So I'm gonna go through a few escape hatches. So if your ship is sinking, you should try to fix the problem. You should try to fix the hole in your ship before using the escape hatches to get away. So these are a sort of last resort. And let's start with any. Don't use any. Period. Let's go on. No. So any basically turns off TypeScript checks completely. And let's refresh so we get the editor working. There we go. So in this function here, we have specified that input is any type. It can be whatever you want. So Typescript says, okay, we gotcha. It's anything, I won't care. And then we do something with the results. We add 6 to our input, and we literally say that, oh yeah, the result is going to be a number. So this function takes anything as an input and returns a number. So if we then call my unsafe function with 5, right, const result, we see that result here, it's a number. And in this case, the number would be 11. And if I do const result 2 equals my unsafe function true, we see that result 2, oh, it's a number. In this case, it probably would be a number because true would be 1, so I think we would get 7 out of this, but never mind. But if we do result 3, my unsafe function, some property. In this case, we're passing an object into this function and adding 6, which will throw a JavaScript error in the browser. However, Typescript just says, this is a number, because you said that anything goes here. And I've seen so many new Typescript users just, oh, let's just plump in any, because I'm getting weird errors. I don't understand them, let's just type it at any and it'll be fine. And yeah, as I said, there's always a better option. Just fix your upstream types. It's worth the hassle. I also see a lot of new TypeScript developers just develop with any and then add types later. And that's just so wrong to me, because TypeScript is there to help you just build your types first, what you expect, and then code according to that. If you build everything with any's and then try to sort of patch types on it, you're not getting the benefit of the types. So either fix your upstream types, in this case, oh yeah, this should be a number, right? And then we get errors. You can also do something called generics. I'm quite sure that app developers know what generics are, but it's basically a way to add types to a function dynamically. In this case, we would say that we could get an error saying that, oh, you can't plus the generic type t because you haven't restricted that to something that is addable. And as a sort of last resort, if you really don't know, you should use unknown instead of any. And that's not spelled like that. There we go. Because now you will get an error here saying input is unknown. You can't add something to unknown. You need to make a check. So what you would do here is if type of input equals number, yeah, you go ahead and do that. And unknown is a good interface to use when you're dealing with the edges of your code. If you're calling a third-party API and you get back something, you really don't know what it is. So the technically correct way is to type that as unknown. Let's say you do a fetch from API, whatever, then result. Then you can type this as unknown. So then you will force yourself to do checks that it matches what you think it is. I will go more into that on the next tool as well. But for now, use unknown. And there are some weird stuff that, for example, JSON parse returns any and not unknown, which is really weird. It should return unknown, but yeah. The other escape hatch is typing with as type. Type assertions, they're called. So here we have a fetch from an external API, and we get the JSON from that result. And that result.json, that returns any, which is, yeah, it should be unknown. There's a great library called tsreset, which changes the return type of JSON to be unknown instead, forcing you to do what I said before. But here you can, I mean, if you know what the API is returning, because you've read it in the documentation, you can return data as user details. So say you've defined user details somewhere that matches the return type of the API documentation. You can say that, okay, yeah, this function will return data, and that will be user details. This is not necessarily true, though. The API could change. I mean, I've certainly been in a situation where a third-party API from another company just changes without notice or documentation updates, and it crashes in production because, yeah, it crashes. So you can't really guard for that. But yeah, I do this if I need to. So type assertion is fine. And another example is the JavaScript map type, which is, it's not that used in web development, I feel, but it's basically a map. So you have a key value pair. It's basically a JavaScript object, but without any unnecessary fluff. And if you do this, a map of strings and key strings and number values, you make an iterator, which is a type that lets you do a loop through it. And then you do .next, which gets the next value in line in the iterator, and then .value. That returns any. So here's an apparent bug in TypeScript. This value here, I mean, we know what it is. It's a tuple of string number. So in this case, we have to tell TypeScript that, oh yeah, this is gonna be a tuple of the key and the value. So there are some cases where type assertions are fine. There are basically no examples where any is fine. And I think I will stop there. Next cool, I will talk about how to parse weird types like this one. I will talk a bit about how to integrate TypeScript with Vue and React. I will talk a bit about API, handling type safety in APIs. Some utility functions, generics, trying to read error messages, and so on. Here are some resources. The TypeScript handbook is a great documentation, and it's basically meant to be read from start to finish in that order. It goes through stuff really well. Matt Pocock I've talked about. His YouTube channel is great, his Twitter is great. He's a really good TypeScript educator. And you will also have access to these slides, which I will send out on Slack later. And you can also find those at par.fyi/talks. And if anyone's interested, I made them with SlideDev, which is a really nice tool to build these kinds of presentations. So thank you, and questions?